I'm in the process of restoring this Reperforator. It's a very old machine. It's used to take input from a keyboard and turn it into punched paper tape. So far in this series I've restored the keyboard, the encoder system and the main chassis. Now I'm currently working on the actual paper tape punch itself, which is what this is. This was really dirty, so I cleaned it up, and initially it was seized up, it wouldn't turn. So I got it freed up, got the primary shaft freed up, and the secondary shaft that carries the anvil was completely seized, so I got that freed up. A couple of the punch pins were stuck, so I took the pins out, cleaned up the head. I didn't show it on camera, but if you want to take these out, all you do is you take the screws out from the bottom, take the top part off the punch block, and then you can withdraw the pins. You can't just pull them out without doing that, because there's a little a snap ring on each one. But when you put it back together, make sure the pins slide freely, otherwise you can damage them. So I've done all that. That appears to be working, but this has now got a subtle fault. So I always test these things before I put them back, and if you're familiar with working on these, you know that sometimes it's the subtle faults that can be the ones that get you. And this appears to work. So if we go through a cycle, so to start the cycle there's a lever underneath that you can't see. If I move that across, it will disengage the stop and it will allow us to rotate the mechanism, and it will go through a complete punch cycle. So if I move the lever, it releases a catch. This then rotates and it appears to be working. The anvil's going up and down, but you may have noticed it doing this in one of the previous videos. It goes so far then stops. That's not the actual fault as such. You can just make it continue, but the problem is if I put some tape in this and we try and run it through a cycle, so at the moment it will often go through the cycle and finish the cycle and appear to be working. But if we now put some of the blocking levers in positions where it's going to try and punch the tape, and then we try and run it again, if I start this running, release the catch, start trying to turn it, it's got to the point where it's trying to punch the tape. Hasn't gone as far as it did before, but notice now that it's no longer turning. Although the input shaft is turning, the output shaft isn't turning. If I just rotate this backwards a little bit and try and get the tape out, and then try it again, notice it goes through the cycle. So what's going on with this? It's fairly subtle. If you know how these work, then it's probably fairly obvious to you already what's going on. But these work in a fairly consistent manner, irrespective of their particular design. In the previous video I mentioned that the clutch on this is fairly similar to the clutches that you get on something like an ASR33. So the idea is that the motor runs all the time, and any time you want a particular part of the mechanism to do something, you just activate one of the clutches. And they all tend to work in fairly similar ways, but there are some important design differences. So what you have is the slipping part of the clutch. So you've got this friction drive here, and you can see that this part is normally driven by the motor, of course. It spins around all the time, and then when you want to punch the tape, you activate it, it engages the clutch, drives the mechanism round, and then it finishes the cycle. So there's a stop here, but that stop is not to actually stop the anvil turning. That's it does do that as a secondary function. But the torque to punch the tape is not meant to go through this friction clutch. This is just here to allow the system to actually operate by applying a small torque to the output shaft, and specifically to this cam. What's supposed to happen, what I'll do, I'll zoom you in so you can hopefully see a bit more clearly what's meant to happen with this. So you can see you've got this lever here, and it's the stop lever. It does two things. One is it mechanically stops this shaft from rotating using this part of this cam. But notice there's a second part of the cam here, there's a little pawl in the middle. Now what's supposed to happen is when you activate the mechanisms, if I release the catch, notice the catch is now released, it's cleared the cam, so this will now rotate. But at the moment all that's driving it round is friction. So if I stop the output shaft from turning, we can still continue to turn the input shaft. and it shouldn't be doing that. What should happen is this small pull should pop up when we start or when we release it. So this catch not only stops this part of the cam turning, this fixed part, but it also pushes down on this part of this pull. But what should happen is this should pop up, and as you turn it, this is why there's a torque applied to this, as you turn it, it will find a position where it will engage with the output shaft. So now it's engaged, and what we've got is this pull, and inside here is a ratchet wheel, and these two are now locked together. And if you can see, I can put a lot of torque on this. Unlike the ASR33 that uses a friction clutch, this uses a dog clutch with a pull and a ratchet wheel. So the two are now locked together, they won't turn separately, but if I disengage this, they will now spin freely and separately. If we re-engage it, it's re-engaged and they're locked together again. So what's supposed to happen is this will normally, at the end of the cycle, if I run right to the end of the cycle, so this latch not only stops the cam from turning, but it also disengages this pull to release the drive. But what should happen is when this lever is released, so if we release it, I'll do a manual start, you'll see this pop out of the way. What's supposed to happen is this pull should pop up, and then the movement from the input shaft on the through the friction clutch should cause the pull to pop into the next available tooth on the ratchet wheel. But this isn't moving, you can see it's kind of loose. It is trying to move, but there's not enough spring tension, and this is pushed across by this leaf spring. So what's happened here, I suspect, is this spring's just relaxed over the years and it's not putting enough force onto this pull. So this is not moving across, so what should happen is this should pop across, and then when it gets to the end of travel, when it hits this lever, it's pushed back, disengages from the shaft, ends the cycle. But it's not moving across to start with as it should do. So what I'm going to do is take off this spring, I'm going to retension it, aka I'm going to bend it, put it back on, and we need enough spring tension to get a very positive movement. It has to move fairly quickly because this is spinning at fairly high speed, so it needs to engage fairly quickly with the main drive shaft. So by the time it gets to this point, which is where the paper starts getting punched, it's fully engaged. Otherwise what will happen is it will seem to be going through the motions, but it will just stop halfway through a cycle and it will fail to complete the cycle, and you wonder why it's not working. Okay, so I'll get this spring removed, I'll bend it a bit to increase the tension, put it back on, and we'll see if it then does what it's supposed to. I've removed the screw, so what I can now do is lift out the spring, and I can increase the tension by simply bending this to a sharper angle. I'll put it back in and hopefully that will resolve the problem. To try to get some consistency when I'm doing things like this, rather than just randomly bending the spring, because of course if you bend it back and forth too many times it will snap, what I do is I draw the original profile on a piece of paper, and then I've got a good yardstick, so to speak, to use as to how far I've bent it. So I've bent the end 3mm. I'll now refit this and we'll see if that's corrected the problem. If not, I can take it to 4mm, etc. But doing it this way means you've got a very good measurement method, so you can tell exactly how far you're going with it. I've refitted the spring, so what should now happen, as I said, is this little pull should pop up on its own, and before it wasn't moving unless I pushed it. But if we now push it back and then release it, notice it's popping up on its own, which is exactly what it's supposed to do. And then if we drive it through to the end of the cycle, it should disengage when it hits this end stop lever, and then if we start the cycle, we should see this center pull pop up. It'll pop up straight away, but then as we rotate the shaft at some point, this pull should engage with one of the teeth on the ratchet wheel, and then it should lock it to the output shaft until the end of the cycle, where it's disengaged again by this lever. So we'll push in the start button. So notice it's immediately popped up. Hasn't come up all the way yet, it's kind of riding on the top of one of the ratchet wheel teeth, But as this rotates, it's now gone all the way up. It's now positively locked, so these two are now locked together, and then as it goes through the cycle, it goes all the way around, gets to the end, and at this point the first thing that hits this stop lever is the tip of the pull. That will disengage it from the output wheel. Output shaft is now disengaged, and I can now continue turning this. So that seems to work. So I'll zoom you out, put a piece of paper in, and we'll see if we can now punch some tape. So I've got a piece of paper fitted. I've moved some of the blocking levers so that some of the pins should actually punch a hole, and we'll start the cycle and I'll rotate it, and we'll see this time if it can complete the cycle rather than stopping just after it's started rotating. So pull the lever across to release the catch. The pull has popped up, so we can now start turning. And at this point before it got stuck, but now if I continue turning, it's gone through the entire cycle, it's stopped, and we'll withdraw the paper and see if it's actually done anything. So it has indeed punched the sprocket hole. We'll now see if we can punch any of the larger holes. So this time we'll pull the levers all the way back, and this should punch at least 2 or 3 of the holes. So we'll try that again. Pull the lever back to release the catch, rotate, let it finish the cycle, and this time when we take the paper out, we have indeed got some nicely punched holes. So this is now working. It's not slipping, and as I said, if I just refitted this, it wouldn't really, it might just about manage to go around and punch the sprocket hole and maybe one other hole, but then it would keep jamming up and it looked for all the world like it had a serious fault, when in reality all that's wrong with it is it just wasn't engaging the pull on the clutch. So I can now get this refitted to the main chassis. Just got one more job to do to the chassis before I can put this on. So I'll get the chassis onto the bench and we'll get that job out of the way. So the chassis is almost ready to accept the paper tape punch, but before I do that I need to refit the CHAD tube. So this just bolts into this location, and it's just used to collect the CHAD coming off the punch and channel it down through the bottom of the machine into the CHAD collection box, or in my case onto the bench. So I'll get this refitted, just 2 screws, and then we can start refitting the punch. So the next thing is to refit the paper tape punch. There are 2 pins on the underside of the punch that locate with these 2 holes, and as long as I haven't disturbed those and moved them, everything should still line up. I haven't disturbed the main settings on the encoder, and on the punch itself there is an eccentric adjuster. I'll show you that once we've got it fitted, that allows you to effectively move the position of the punch head back and forth, but again I haven't moved that, so in theory it should all still line up, but we'll check that once we've got it reassembled. So I'll drop this over the, I can't really show you on camera, it's quite a delicate operation. I need to lower the heavy punch over these without doing any damage, but as soon as I've got it into place I'll get back on camera and we'll see how to reconnect it to the rest of the machine. I've lowered the punch mechanism back onto the chassis and I've refitted the 3 screws that hold it down. The screws don't align it, it's these 2 pins that align it, but I haven't moved those, so it should still be in the right place. And the eccentric I was talking about for adjusting this, unfortunately you can't see it, it's down here, but what it does is it allows you to very accurately move this punch block back and forward, so it puts the basically the encoder and blocking levers in exactly the right place. The next thing I have to do is refit the guide plate. So this is just the plate that sits underneath these levers, and it spaces them and aligns them correctly. And then the next thing is I have to refit the blocking levers into the arms that come from the encoder. Unfortunately I forgot to show this, and it's quite difficult to see, so I don't know if you can actually see this. I'll zoom you in so you can have a closer look at this. Okay, so the front encoder bar we don't actually use in this machine. The ones we want are the rear 5, and what we have to do is take the end of this sort of keyhole shaped link and it goes into the recess, there's a matching recess in the end of the encoder arm, and then we have a little spring clip we put on to keep it in there, and we do the same thing with all 5. So I'll get that done, I'll get the plate fitted, we'll get these refitted, and then we can reconnect the link that comes from the start encoder bar. That's the one that pushes that lever across to start the cycle. So I'll get these refitted and we'll go on from there. I'll try and show you the last one of these. I've done the first 4, and what we're trying to do is get this blocking lever to engage with the appropriate encoder bar. So what we do is we just push the encoder bar down that we want to currently engage with. So we push this back, okay, so that's now into the right place, and we can now put the end of the blocking lever into the keyhole cutout that's in the encoder bar, and the last thing to do is fit the spring clip to keep it there. So the easiest way of fitting these, it's just a bent clip, it's sprung, push a screwdriver or something into it, you can then lower that over the end of the encoder bar, hold the clip, pull the screwdriver out, and then when you push it down there's a little dimple on each side of the clip and you'll feel it kind of click into place. I'm trying this without getting in the way. So as you push this down it clips into place, and if you slide it back and forth it shouldn't slide all the way off. If it slides all the way off, obviously the dimples aren't engaged. Okay, so that's all those reconnected. What we can now do, again I can't show you this, it's very difficult to see, but if you remember there was a link that moved every time you pressed a key. I need to reconnect that to the lever that was sticking out of the bottom of the punch. It's just clipped into place, but you can't really see what you're doing, you have to do it by feel. So I'll flip this over, get that reconnected, and then this should actually start to work. Okay, I've got the link reconnected down below, so the next thing is to fit this guide plate, and it just fits up underneath these arms, and it's just held in place with 2 screws. So I'll get the 2 screws put into place, and we can then try and run this through a manual cycle. I've got the guide plate bolted back into place, and I've got the machine set to character mode, and what you notice now is if I push a key, at least if I push it part way down, then you'll notice that the encoder bars will take on a code depending on the key that I press. However, if I press the key all the way down, then I can't then press other keys. So now it's kind of stopping me pressing some of the keys. I'll come back to what's causing that in a few minutes. But the first thing we want to do is see if we can actually cycle this through a complete punch sequence and see if it actually works. So I've pressed the key so the catch is already disengaged. We'll now cycle the punch. Goes right the way around, and it's finished punching. So we'll try and press a different key. As I said, I can't now press any of the keys because these are now all in the wrong place, so we'll push them back to a neutral point, press a different key, and then we'll try and cycle it again. The catch is disengaged, we'll cycle it all the way around, and it's finished the cycle. So that appears to be working. I'm just going to try one more time. Okay, so that's good. Also I should say that the advance wheel here, this sprocket wheel, is turning, but it's not engaged with the paper at the moment, so it's not pulling the paper through. Also, the other things to look at on this, if you're getting problems, is during the cycle we've got this catch here at the front, and what that's for is to pull the pins back out of the paper. If that's not there, the pins could end up being caught in the paper, and then when the paper tries to advance it tears. So this is this catch is underneath the little tabs on the little clips on the pins, and it actively pulls them up, and you can see it moving. It's on the end of this, you can see it moving at the end of each cycle, and then you'll see the advanced pull, the advanced sprocket turn. Okay, so this appears to be working, but the next question is what's meant to position these, because at the moment I said they're all moving to the wrong place. And let's zoom the camera out and you can see a bit more clearly what's going on here. So what's happening with this is these encoder bars are moving to the wrong place. They're going slightly too far in one direction or the other, and that's what's stopping them behaving properly when you press another key. So the way this is meant to work is it doesn't go back to a reset position at the end of each cycle, it stays in its current position, and then when you press another key it goes immediately to that new position. So it will go, for example, from the W combination if you press the W key to the T combination if you press the T key. It won't go through a kind of neutral reset state, it will go straight from one to the other. But these are moving too far. Now the reason they're moving too far is that there is of course a piece missing off this. I do have it, it's not lost, and it's operated by this cam up here. So we'll get that onto the bench and have a quick look at it. We'll refit it and see if this then starts to operate correctly. So this is the piece that hasn't been fitted yet, and this is the character counter. So this counts characters as they're typed, tells you how far across the line you are. Because of course there's no paper output on this other than the punch tape, so the operator doesn't really know where they are on the imaginary paper they're printing onto. Don't forget that the paper tape might be used as text output when it's fed into a printer. So they need to keep track of where they are on the kind of imaginary line on the information they're putting onto the tape. So this counts key presses. This also performs another function, which is the end of line detection. So the way this works is this lever is operated by that cam we just looked at, and normally at the end of the cycle it's held in. If you release it and unrelease it on each cycle, then what it will do is it will count characters, but it only does that if this lever is in a certain position. So if it's in this position and we push this lever in and then we let it out slightly, you'll notice that each time I do that it's counting up by 1. But if we let it out all the way, this pops down and this goes back to 0. So this is normally controlled by the encoder bars, so we'll have a look at that and see how this is meant to operate. But just bear in mind that this plate determines the function of this, whether it resets or whether it counts up in response to each cycle of the machine. So that plate we just looked at normally sits in this location, and what happens is it tries to drop down every time a key is pressed. So if I press the key, it's in this position. Now it can't drop down in this case because it would hit both this tab and this one. If I press a different key, so these go into the wrong place, so I need to keep resetting them. If I press a different key, again this time it can't drop down because it would hit this, this and this. If I press a different key, still the same thing, it still can't go down. If I press another key, notice this time it can drop all the way down, and that key I just pressed is the carriage return key. So that's the only time the bar can go all the way down, so then it can drop all the way down into this space. Any other key, if we reset these, any other key that I press, there's always at least one tab in the way that stops it dropping down. So the carriage return key allows that plate on the counter to drop all the way down, prints the carriage return character, and that resets the counter as well. I've got the character counter bolted back into place, and this is the bar we were talking about. So this prevents the encoder bars moving too far. What I can now do is press a key. So if I press, in this case I'll press the T key, it will release the catch that's around the back of this. You can't see it, but I will then manually turn the machine round and you should see the counter increment, and you should also see this bar trying to drop down into that recess we were looking at. It won't be able to because the T key doesn't allow the carriage return and so it won't allow the counter to reset. So I'll press the key, it's released the catch, I'll rotate, you'll see that you saw the counter go up. We'll finish the cycle. The plate tried to drop down but it couldn't. That's the end of the cycle. I'll press the J key, you'll see the encoder bars move to a new position. It's released the catch, so I can now rotate the machine. You'll see the character count go up. The plate's trying to drop down, but it can't because there is at least 3 bars in the way. We'll finish the cycle, and then the plate goes back to its rest position. I'll press the B key. You'll see the encoder bars move to a new position. It's released the catch. I'll start to turn the shaft. You'll see the counter go up, and the plate again tries to drop down, but it can't because at least in this case 3 more bars are in the way, and then it goes back to its rest position. So this time I'll press the carriage return key, so that will move the encoder bars to a new position. It will release the catch, but this time there's nothing to stop this plate dropping all the way down, so that will reset the counter. So you see the counter's reset, the plate's gone all the way down. We'll finish the cycle. It will of course print the character, and it's now ready for the next character. So I'll press E. You see the encoder bars move to a new position. It counts the character. The bar can't go all the way down this time. Finishes the cycle. I'll press R, and it repeats. So press carriage return one more time. You see the counter goes back to 0. And so it's working. Now normally this would all happen very quickly because the motor would be spinning all the time, and it would then punch the paper tape, feed the paper, and move on and wait for the next character. Looking on the other side, we do have this knob here. This is a manual start button, so if we press this, it's the same as pulling that start lever across on the underside of the punch. So if we press this down, it releases the catch that allows the cycle to start. This lever at the front is the backspace lever, so this just turns the sprocket wheel back one position. So if you want to repunch the same character in the paper, you just push this and it will move back one sprocket position. Okay, that's it. So the next thing I'm going to do is zoom you out. We'll pull the tape through far enough to get it to automatically feed, and then we'll try printing a few characters, manually turning the machine, and see what comes out of the other side. Okay, I've got a piece of tape fed in. I fed it through far enough to punch some sprocket holes so the tape will advance automatically, and you do that with the this button on the side is a manual override. It was like a manual start for the cycle, but unlike a key on the keyboard, the machine will keep cycling as long as this is held in. So it's normally used to advance the tape or to create leaders or something like that. So what we can do now is press a key on the keyboard. I'll rotate the mechanism. It should print the character. Get to the end of the cycle. I'll press another key and it should repeat. You'll see the tape advance each time. I'll press another key. So as you can see, it's working. We are indeed getting characters coming out. Okay, I'll now manually pull the tape through. Okay, and you can see it has successfully punched the characters. Still needs some work, and you can't really start adjusting this properly until it's running at full speed, because it will behave differently at speed than it does when it's going around slowly. It also needs to be cycled quite a bit just to free it up and get it working properly, and then we can make any small adjustments that are required. So the next thing to do, which we'll do in the next video, is to get the motor refitted. So we'll work on the motor, see what it needs doing if anything, and then we'll get it refitted to the chassis and see if we can power this at the proper speed.